Now let us see two important results related with arc and sector of a circle. So let's consider a circle with radius as r. Now if there is some arc which subtends an angle theta radians at the center, then length of the arc, that means this particular curved length, right? So the length of the arc S, that is given by r into theta, that is radius multiplied by the central angle, but it should be kept in mind that the angle theta must be in radians, right? So that is a formula for length of an arc. Now any arc, when you join the endpoints at the center, it will form what is called as a sector. So therefore this entire shaded portion, that is called as a sector. So the area of that sector is given by the formula half r square theta. Once again, theta has to be in radians. So let us solve few sums based on these formulae. Find the length of an arc of a circle that subtends 108 degrees at the center if radius of the circle is 15. So writing down the given data, we have central angle as 108 degrees, and if you remember, we have to convert the angle in radians. So that is 108 into pi upon 180 radians. So 36 3s are and 36 5s are, so that is 3 pi by 5 radians, and the radius is given as 15 centimeter. So to find the length of an arc, we use the formula S given by r theta. R is 15 into theta is 3 pi upon 5. So therefore cancelling 5 with 15, that leaves us 3, and 3 into 3 is 9 pi. So that is the length of the arc. If you want, we can approximate it by writing pi as 3.14 and get the final answer, right? So that's the way to calculate the length of arc. Let's see another problem. Find the area of the shaded region in the figure. So if you observe, here is a circle of radius 12, and there is an arc which subtends an angle 60 degrees at the center, and when you join the endpoints of the arc, that becomes a chord, and basically that forms the triangle AOB. The area which is shaded in yellow, that area is precisely what we have to calculate. So it's clear that the shaded area is nothing but, we have to subtract the area of the triangle AOB, right? Area of this particular triangle we have to subtract from the area of the sector in which that triangle is present, right? So therefore we go ahead and calculate the shaded area as area of sector AOB minus area of triangle AOB. Now the formula for area of the sector we have seen, that is half r square theta minus. Now let us see what is this triangle AOB. We know that OA and OB are both radii of the same circle. So therefore the two angles as shown here in green, they must be of the same measure. But since one of the remaining angle basically 60 degrees, so sum of these two green angles must be 120, and they both being the same, each one has to be 60 degrees. So basically that means the triangle OAB is nothing but an equilateral triangle with side as 12, correct? So therefore, as we know, the area of an equilateral triangle is root 3 by 4 into side square. That's the formula for area of an equilateral triangle. So therefore substituting the values, we have 1 by 2 into 12 square into, now 60 degrees in radians is nothing but pi by 3 minus root 3 by 4 into side of the equilateral triangle is nothing but same as radius, which is 12, so 12 square. Now we can take 12 square upon 2 as common from both, so that leaves pi by 3 minus root 3 upon 2, so that equals 72. If you want, we can merge even the terms inside the bracket, so that gives us 2 pi minus 3 root 3 whole by 6, which is the LCM, and 6 will cancel out 72, leaving 12. So we get 12 into 2 pi minus 3 root 3. That's the area shown in shaded way. So we can keep pi as it is, or we can convert into approximate decimals and get the final numerical answer also if required.